Okay, so we're back here in example 5, talking about a rhombus. So I'm actually not going to do the first one, all right, because the first one is dealing with parallelograms, and I want to talk about specifically rhombus stuff. Okay, so let's go to the next one. So now we're talking about angle CDB, all right, so angle CDB is 6y, and then it says that angle ACB is 2y plus 10. Okay. So here is the deal, all right? We have to use both of the properties of the diagonals of a rhombus in order to solve this question, all right? So the first one is that they're perpendicular. So I'm going to mark that as perpendicular, okay? And the other portion is that they are angle bisectors, all right? Which means that this angle right here is 2y plus 10. So if we look at this triangle right here, all right, what do we know about those three angles? We know that they have to add up to equal 180. So that's exactly what I'm going to do. All right, so I'm going to do 2y plus 10 plus 6y plus 90 is equal to 180. So solving that, I'm going to get 8y plus 100 equals 180. All right, subtracting that out, I'm going to get 8y is equal to 80, which means that y is equal to 10. Okay? All right, now let's look at the next one, okay? So the next one gives us AD and CD, and what we know about a rhombus is that all the sides are congruent. So all I'm going to do is set them equal. So I'm going to do 2x plus 4 equals 4x minus 4. I'm going to get negative 2x is equal to negative 8, which means that x is equal to 4. Okay, last one says that if I'm giving angle CBD, all right, that's 58 degrees, and I need to find angle ACB, so this angle right here. And again, it's based off of the fact, all right, that that's perpendicular. So all I have to do is 180 minus 58 minus 90, which means that that angle is 32 degrees. Okay. All right, guys, so that was example 5. We're going to go to example 6, all right, and it says, using the figure below, find the missing angle measures if angle EZY is 47 degrees. All right, I'm telling you that this is a rhombus, okay? So go ahead, you can mark all those sides as congruent, and it's telling me that EZY is 47 degrees. So even though it's not drawn to scale, all right, we know that if it's a rhombus, then the diagonals are perpendicular. So I'm going to go ahead and mark all of these angles right here, 90 degrees. And so then from there, guys, all right, I can also recognize that, all right, my diagonals are angle bisectors. So that means this angle right here is 47 degrees as well. And if I travel along that transversal, all right, this angle is 47 degrees, and this angle right here is also 47 degrees, okay, because of alternate interior angles. So that now brings us to finding, how do I find like all of the rest of the angles, all right? And that's based off of the triangles. So if you take a look, all right, at this triangle right here, I have the 90, all right, I have the 47, and now I need to find this angle right here. So all I have to do is 180 minus 90 minus 47, and this angle right here is 43 degrees, all right? This angle right here also has to be 43 degrees because it is an angle bisector. And then following along the transversal for our alternate interior angles, we got 43 degrees and then 43 degrees. And there we go. All right. Okay. Now we're going to do, we're actually going to pop down. All right. We're not going to worry about example 7. And we're going to, I mean, you can do example 7 on your own if you want. All right. But let's do this proof. Okay. And then we'll be done. So for this proof, all right, we're going to go ahead and state that QTVW is a rectangle, and then that QR is congruent to ST. Okay, so we're given that QR is congruent to ST, and we need to prove that triangle SWQ is congruent to RVT. Okay, so let's talk about what we know about rectangles. First thing that we know is that all the angles are right. All right, so I'm going to state now that angle Q is congruent to angle T. All right, because of definition of rectangle. And then we also know, so I'm going to mark those. Those are right, okay? And I also know that QW is congruent to TV. Because it's a parallelogram, which means that opposite sides are congruent. Okay. So what we're essentially going to now have to do, guys, all right, if I could just guide you, is that I'm going to have to prove that QS is congruent to RT, okay? And so I'm going to have to do that using definition of congruence, all right? So I'm going to do QR equals ST, and that's by definition of congruence. And now that's going to take us to our old best friend, all right, of segment addition. So I'm going to do QR plus RS equals QS. And then I'm going to have RS plus ST equals RT. And that's segment addition. Okay. All right. So from there, guys, all right, I'm going to do a substitution where I'm going to take QR and I'm going to plug it in for my ST right there. All right. So I'm going to now do RS plus QR equals RT. So that's through substitution. And what I'm going to notice after I do that is that RS plus QR matches, all right, RS plus QR up here. So I'm going to take this QS and I'm going to plug it in to this side, and I'm going to have QS equals RT, which is through substitution. So I've just now proven that this side length of QS is now congruent to this side length of RT, which is exactly what I wanted to do. All right, I now just have to change that into congruence. So I have QS is congruent to RT, and that's by definition of congruence. Okay, so from there now, I'm actually ready to state, all right, that the triangles are congruent. So I'm going to do triangle SWQ is congruent to triangle RVT, and that's by side angle side. All right, guys, I hope it made sense. Let me know if you have questions, okay?